Hello again, viewers. We are back again with Quest, the weekly inter-school science quiz brought to you by Doordarshan Kendra Kolkata and the National Councils of Science Museums. I am Gaurav Gupta. I will be hosting your show today. But before we move any further, I'd like to request the Director of National Council Science Museums Headquarters, Dr. Jayantos Thanapathy, to please come up. Please give him a big hand as he walks in. Dr. Thanapathy, today
Yes.
your experiments are going to be more towards chemistry or physics?
It's balanced.
It's balanced?
Yes.
All right. Well, I'd like to now move on with introducing the teams to you. On my right, J.C. Bose's team. You are?
I am Atul Srivastava from St. James School.
I am Kanjana Bhattacharya from St. James School.
Hi, this is Shantanu Bhaumik from St. James's School.
Nervous today, boys?
Little bit.
Little bit. Okay, that's a good sign. And on my left, the C.V. Raman team. You are?
South Point High School. I am Devadeep Shen from South Point High School.
I am Shayan Chakraborty.
I am Shyamindu Dasgupta from South Point High School.
Now, if you watched our show earlier, you would know we will ask you 7 questions in all. The first 4 will be direct questions, 20 points for every correct answer, and 10 if you answer it on passes. Approximately 15 seconds to answer your direct questions, at the end of which it will go to the other team. If both teams do not answer, we go into the audience. The last 3 questions will be on the buzzer, plus 20 if you get it right, and minus 10 if you do not get it right. But teams, do remember one thing. If you hit the buzzer and you do not have an answer, you lose 10 points right away. So be judicious, think carefully before you hit that buzzer. One more thing, teams, do remember, good quizzing is good teamwork. So do remember to confer with each other, to talk to each other, and then decide who is going to answer on your behalf. So without wasting any further time, let's move on to the very first question of today's show. Dr. Thanapathy. The first question in today's show, as is usual, will go to the team seated on my right. That's the J.C. Bose team. Over to Dr. Thanapathy.
In this arrangement, I have kept a magnet suspended from these 2 rods. And there is a coil here which is made of tungsten. Now I am going to pass current through the tungsten wire. The magnet is released from the tungsten wire. When I have already passed current for some time through the tungsten wire, it gets heated, and so long it is heated, it releases the magnet. It doesn't attract the magnet. If I switch off and let the tungsten wire cool down, it again attracts the magnet. What is really happening here when I switch on the tungsten?
Aligning of molecules change.
What is really happening here when I pass current through the tungsten wire?
Magnetic field is set up.
Due to the heat, the aligning of the molecules changes, and the magnet no longer has a.
You must hurry up with your answer, boys.
Due to the when the current is passed, due to the heat that is formed, the alignment of the molecules gets changed. Where in the tungsten wire.
In the
magnet which is in contact with the tungsten wire,
okay.
And the alignment of the molecules there gets changed. So the charge, the concentrated charge, whatever it may be, north or south, doesn't quite remain there. So the magnet swings away. When it remains, it is allowed to cool. The alienation orients themselves again, and so the north or south pole charge comes again, and so it again attracts the tungsten wire.
My friend, when I have kept it on, okay, the tungsten wire gets heated, and you are saying the magnet is also getting heated. but the magnet is released from the coil, so it's getting cooled. This will attract back only when I switch off the tungsten.
It cools down, then it again attracts.
I'm sorry, that's not the correct answer. We'll go to the other team.
Sorry, Shantanu, you don't have the right answer. Yes?
We know that when we bring a magnet near other some ferromagnetic stuff, it attracts that thing.
Okay.
Because the magnet has its own polarity and it induces the Weber elements inside the other thing, which is ferrous in nature, to align itself with according to the alignment of the Weber elements inside the magnet. Hence, that thing also becomes a pseudo magnet, and hence the two magnets attract each other.
You mean to say in this case,
but in this
tungsten is the magnetic material?
In this case, the magnet is the actual magnet. It is remaining like a magnet throughout.
Okay.
But when we are before hitting the tungsten, the magnet is aligning the Weber elements inside the tungsten filament in order to attract it. But when it is being heated, we are supplying extra energy in form of heat to the Weber elements, and hence they get disaligned.
We are applying heat where?
On the
tungsten wire?
On the tungsten wire. Hence the Weber elements inside the tungsten wire get disaligned, and hence it does not function as a pseudo magnet anymore. Hence the magnet does not attract. This is because of the Curie point of the
Absolutely right. That is the right answer. Very good. Well done.
CV Raman team, Shayan, you've done extremely well. Dr. Stanapati, why don't you give us a more detailed
My
explanation?
explanation is like this. You see, the tungsten is a magnetic material, and a magnetic material is attracted by a magnet. When there is no current passing through the tungsten coil or the wire, it is a magnetic material and it is attracted by the magnet. In this case, the magnet can move, so it is moving towards the coil. It is attracted. When I am passing current through the tungsten wire, it gets heated. When it is red hot, it loses its property of remaining a magnetic material. It becomes a non-magnetic material, so it releases the magnet. And as they have said, there is a particular temperature for a particular magnetic material above which it becomes non-magnetic from magnetic, and that is the Curie point.
Well done, CV Raman team, you pick up 10 points. This experiment was about the Curie point, and in this case, it was not Madame Curie, but her husband, Pierre Curie. Well done. Scores at this stage, JC Bose team yet to open their account, and the CV Raman team are on 10 points. The next question is for the CV Raman team.
I have a structure here. This is stable.
Okay.
I am deforming it. Even now, this is stable.
Yes.
If I deform it further, when will it become unstable?
Can we start answering?
Yes.
When the center of gravity, that is, I think at the point where the string is tied, I think its center of gravity is there, and when that point crosses the line, the imaginary line, which would be if we connect the two legs on this side, and if that point crosses, that point gets to the right of that virtual line, then this would topple, because for a thing to remain stable, the clockwise and anti-clockwise moments by the reactions from the floor on the different legs should equal each other. But here, if we are moving it too much away, then the gravitational force would have a moment which cannot be balanced by that leg, because it does not take any weight there, hence it topples. So it will topple when the CG is out of that square, which is
the base.
Out of the base.
Okay, that is the answer. Very good. That's the right answer.
So a big hand for them. Tell me, Dr. Stanapati, a layman's point of view,
Yes.
what if I had said to you that when this top line crossed this one, it would become unstable? Would that be the right answer?
Right, right.
Why don't you throw some more light on
Okay.
it? Yes.
The structure as it is now, the CG of this whole structure is passing through this point where I have fixed a bob. And so long this bob is within the base of the structure, it is stable. Now, in this case, it is just crossing the baseline, this line. So, it is unstable. If I can bring the CG back within the structure, that means within the base, this becomes stable. So long CG of an object is passing through the base of that particular object, this is stable. If the CG is away from the base, it becomes unstable. That's the right answer.
Thank you, sir. 30 points then to the C.V. Raman team, and the J.C. Bose team who will be answering the next question have yet to open their account. Come on, boys. Let's hope you do better with the next question, which is your direct one.
I have potassium permanganate in this beaker, and I am adding a few drops of glycerin in it. Watch what happens. Smoke is coming out. It makes cracking sound. And finally catches fire. What type of reaction is this? Glycerin is reacting with potassium permanganate.
So what type?
Just we have to tell what type of reaction.
Yeah.
This is an
Exothermic reaction.
Exothermic reaction.
Heat is being liberated
Heat is being
after the reactants have reacted completely.
Okay.
So the smoke is coming out, and finally the product catches fire.
Yeah. Can you tell me what happens to glycerin? Oxidized.
It is
That's
oxidized
right.
to carbon.
And what about the potassium permanganate?
Reduced.
Obviously, this is reduced. So you get full marks for that. Very good answer.
Shantanu, surely that was a very simple one for you. Well, Dr. Sthanapati, I have always known you to be a man of very gentle disposition. How come we see the volatile side of you today? Tell us more about this one.
Okay, what they have said is absolutely right. You know, here glycerin is oxidized, and obviously potassium permanganate is reduced. And this is an exothermic reaction, due to which heat is generated, and that creates a fire.
On to the scores then. J.C. Bose team have finally opened their account. They've got 20 points, whereas C.V. Raman are on 30 and face the very next question, which is the last of our direct ones.
I have 3 identical bars. All are metal bars. One of these is a non-magnet, and one is of magnetic material, and the third one is a magnet. You have to tell me, how can I identify which one is magnet and which one is made of magnetic material? But I cannot hang any of this. That is the restriction. I'll follow your instruction. Whatever you say, I'll do that.
We'll bring two close together, two of them.
Close together.
Two of them close together.
May I take these two?
Yeah.
Together.
So nothing happens.
Nothing means?
They do not attract each other.
They are not attracting each other.
So one of these must be a non-magnetic substance, and the other must be a magnetic substance, not a magnet.
Okay.
Okay. Now we take one of these and the other one.
Right.
Okay.
Anyone.
Say this one.
Yeah. So one of these and the other one.
And the other one.
No,
The
spare
the
one.
remaining one.
Yeah, the remaining one.
Yes.
And we bring them close together.
Bringing them close together.
No, it is not attracting.
Not attracting.
So that one must be a non-magnetic substance.
That
The
one which
other
is in
one-
my right hand.
Yeah.
Okay.
That one must be a non-magnetic substance.
Non-magnetic. Discarded.
Okay. Now we bring those two close together.
Attracting.
Yeah. So one of them is a magnet and the other is a magnetic substance.
Yes.
Okay. Next what?
Magnetic substance.
One thing is a magnet and one is a-
Come on, Devadeep, you've done very well so far. You must get the rest of the answer for us.
Can we break it?
No.
Oh, no.
One is a magnet and the other is a magnetic substance. Okay. Now it seems a little clumsy, but we'll follow the single touch process, and we'll take one and rub the other over it.
Okay, I'm taking this one.
Yeah.
Rubbing it over the other.
Yeah. Okay.
So take 100 rubbings.
And repeat the same.
Excuse me, can I
Okay.
do this step? We will take any one and
Anyone? I'm taking this one.
suppose this one, and we will point this to the center of the other one. Does it attract? It attracts.
No.
Then the one in your upper hand is the non-magnetic
It is a
one.
magnetic
It is a magnetic substance, not the
not the
magnet.
magnet.
This
And
is not the
lower-
magnet. That's right. You are
And that
right.
is the magnet.
Now,
Why?
why?
Because in a magnet we know that only the
yes.
ends have polarity and the middle part does not have any polarity. Hence, if you bring a non-magnetic if you bring a magnetic substance but not a magnet towards its center, it will not attract.
Very good. Now, if I do the other thing,
It will
I
attract.
take the magnet in my hand and touch it at the center. This
It will
attracts.
attract.
So, absolutely right answer. Nothing more to add.
Very good answer there, Shayan. After Devadeep had done half the work for you, you were able to explain very well which one was a magnet and which one was not a magnet. In the process, you have picked up 20 points for yourselves. Scores at this stage, 50 points to your team, C.V. Raman, and J.C. Bose, you remain on 20 points. The next question will be on the buzzer.
I have cupric hydroxide in my left hand and ammonium hydroxide in my right hand.
Okay. Answer from you, J.C. Bose team. What do you say?
So when the ammonium hydroxide is added to the cupric hydroxide
Okay,
solution,
I'm adding that.
deep blue solution is formed
Deep
due to
blue
the formation
solution.
of tetramine copper, not sulfate. This is not sulfate. When in excess, the ammonium hydroxide, when in excess, it produces tetramine copper ion, which removes the precipitate which was there previously due to the
What
formation
is the name of the compound?
tetramine cupric hydroxide.
That's
Right.
a complex compound.
Tetra we know, cupric
hydroxide.
hydroxide, not sulfate. There is no
Not
sulfate
sulfate,
there.
not sulfate.
Okay, that's the right answer.
Well, one thing we know that J.C. Bose team and Conjonobo, have I got your name right? They tell me he's called Sunny at home. Anyway, well done, Conjonobo. You pick up 20 points there and move on to 40 points. You're still 10 points behind the team which is leading right now. That's the C.V. Raman team. And we move on to the second last question. in the Inter-School Science Quiz Quest.
I have a bottle here.
All right.
Okay, you have to give the answer.
When we'll press that bottle, when we'll squeeze that bottle, that dropper will move down.
Squeezing the bottle,
The
and
dropper
the
is going to
dropper
move
goes
down.
down.
Because when we are squeezing the bottle, the dropper is also being squeezed inside because the pressure inside the bottle is being decreased, is increased. Hence the dropper is also squeezed. Hence the air which is inside the dropper is squeezed. Hence the buoyancy of the dropper decreases and hence it sinks.
Say it once again.
When we are squeezing the bottle,
Yeah.
the air pressure inside the total bottle
Yes.
is increasing.
Okay.
And hence by Boyle's law, the air inside the dropper is also having a decrease in volume. Hence with the decrease in volume, its buoyancy also decreases, but its weight remains same. Hence it sinks.
The dropper.
The dropper. The air inside the dropper shrinks.
I have fumbled. You have said that if I squeeze the bottle, the dropper goes down.
Yes.
That is absolutely right. And next you have said that the dropper is also getting squeezed.
No, the air is coming out of the dropper.
No, air is not coming.
No. When
No.
we are increasing the pressure, the volume of the air inside the dropper is getting reduced by Boyle's law because P is directly, volume is inversely proportional to pressure. Because when we increase pressure, the volume decreases, hence the buoyancy also decreases because it is displacing less water then and hence it sinks.
You know, the dropper which is there inside, the bottom of the dropper is open and the dropper is partially filled with water. It has been filled in such a way so that the water displaced by the dropper, the weight of that water and the weight of the dropper including its water inside is equal. So it's floating.
Yes. Just floating.
Just floating. When I give pressure to this, when I squeeze the bottle, what happens? Some liquid from the bottle goes inside the dropper and makes it heavier, so it sinks. That's the answer.
Yes.
Because if you would notice, this bottle is sealed from the top,
Yes,
right?
rightly
That's why
pointed out.
its pressure
Yes,
is getting
yes,
increased. when
that's the
it's
correct answer. Sorry, no marks to any team.
No points to anybody, but -10 to you, C.V. Raman. You have been able to squeeze yourself out of the lead. 40 points to each team, and we go in to a nail-biting finish, which is the very last question of today's show on the buzzer.
I am releasing this wheel.
Okay, what's your answer?
Explain.
It is going down because of gravity, but while going down, it has the potential energy is lost and it is translated into a form of rotational kinetic energy. Now, the rotational kinetic energy needs to be conserved as well as the angular momentum, hence it goes on swinging and it winds itself up the wire.
Very good. Very good. That's the correct answer.
Thank you, sir.
Well done, Sharon. With that brilliant answer, you certainly clinched it for your team. Dr. Sanapati, I'm sure you have something to add to that.
No, what they have said is absolutely right, but I am repeating the same thing once again. When
I hope it's not because you want to play with the yo-yo again.
oh no,
No, all right.
when the wheel is at the top, it has acquired potential energy, and all the objects in this universe, they want to go to the lowest potential state. So it will come down. While coming down, the potential energy is converted into rotational kinetic energy in this case, and you know the energy is conserved. So it has to move up towards the initial position, but because of friction and
move
other
up
losses, it cannot go to the
Top.
point from where it started.
With that, we've finally come to the end of today's show. A nail-biting finish. In the end, the winners, C.V. Raman team, the boys from South Point High School. Thank you for coming for our show. A small memento from Doordarshan Kendra Kolkata, from Quest. Thank you. Let's have a big hand for them. Devadeep, Shayon, Shayomindu. And now, the other team, J.C. Bose team, is the team from St. James School. Shantanu, Kanjanaba, and Atul. Thank you for being part of our show. If you've liked our show or would like to take part in it, do write in to us. Our address, Quest, care of Doordarshan Kendra Kolkata, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. From all the team at Quest, it's time to say goodbye once again. We'll see you again next week at the same time. Don't forget to tune in and watch your favorite inter-school science quiz, Quest.